Okay, here we go. Simplify the following expressions. Today we're going to do ones that are slightly more difficult. And today, as we look at these, kind of some unconventional, meaning that yesterday everything you did was pretty intuitive, but today not as much. So if I want to simplify this problem, a lot of people look at secant squared minus 1. What is secant squared minus 1 equal to? Tangent squared. But secant minus 1 is not a tangent. What we can do is this. I can put secant squared minus 1 in for tangent squared. Now, some people might be like, well, why would you do that? You're just, you're kind of going in reverse order. Well, this is the difference of two squares, isn't it? And this factors to secant of theta plus 1 and secant of theta minus 1, correct? Top factors. On the bottom, I got secant of theta minus 1. So I can cross off the secant of theta minus 1s. I get secant of theta plus 1. So I get it that, it's a little bit challenging. I get it. For B, similar type of problem, what do you think you substitute in for sine squared? One minus cosine squared of theta. And I know that 1 minus cosine squared factors because it's the difference of two squares. That's also written on your sheet. So I have cosine of theta plus 1 over 1 minus cosine of theta times 1 plus the cosine of theta. 1 plus cosine and cosine plus 1, are those the same? Why? Why can't you just move it around? Addition is commutative. And so addition and multiplication are commutative. Subtraction, division are not. Cancel those off. You get 1 over 1 minus cosine theta. That's the answer. You'd like me to put a box around that, Allison, wouldn't you? Okay, here we go. C. Distribute. And when I distribute, I will create a squared. So I would say one of the pieces that you're learning today is that sometimes you need to create a squared. When you have something squared, there's a lot of pieces you can substitute in for that. So I multiply, I get secant squared of theta minus, what's secant times cosine? What's the relationship between secant and cosine? They are reciprocals. So when you multiply them, you get 1. Just like secant, just like 1/2 times 2 is 1. Okay, 7/3 times 3/7 is 1. Secant and cosine are reciprocals. So when we multiply them, we get 1. And secant squared minus 1 is tangent squared. Okay, D. Yep. Now I'm going to multiply through by sine. What's sine times sine? And then I have sine times cosecant, which is 1. So you get 1 cosine squared. No, multiplication you distribute over addition. So there's only 2 terms that I distribute sine to. You don't distribute to the cosecant and to the cosine squared. This is 1 term because it's being multiplied together. So if you multiplied it by both cosecant and cosine squared, you'd be distributing the sine twice to that term, and you don't want that. Okay. So I sine squared plus cosine squared is 1. Flip it over. So here we go. We've got, you see that the cosines cancel. Who can tell me why the cosines cancel? These 2 are what we call, starts with a C, rhymes with conjugates. Conjugates. And conjugates, when you multiply them, the middles cancel. So you get 1 minus cosine squared of theta. What's 1 minus cosine squared? Sine squared of theta. F, you multiply it. They're conjugates. So you get tangent squared. Minus what? Secant squared. That looks familiar. Actually, your sheet says that secant squared minus tangent squared is 1. So tangent squared minus secant squared would be negative 1. If you don't see how that works, watch the substitution I'll use. We all agree that tangent squared is secant squared minus 1, right? We all know that. That's written right on your sheet. So if you put that in and go minus secant squared, the secant squareds cancel, you get negative 1. There's lots of ways to do the problem, but that's one way. How about G? You FOIL it out, what do you get? 4 secant squared of theta minus 4. Uh-oh, there's a 4. What to do? Factor it out. What's secant squared minus 1? So you got 4 tangent squared. Like I said, on your test, I don't really think that there's a problem you haven't seen before that we haven't done. But I'm just trying to show you as many as I can so you can get that practice, that recognition of what happens when. H is a little bit different. There's no squareds, are there? There's nothing that cancels. So when in doubt, change it to sine and cosine and see what you can develop. There you go. I got cosine times sine over cosine plus cosine over sine times cosine over 1. What happens? Sines do not cancel. The cosines, sines do not. Okay, they're separated by addition. You can't cancel parts. Now, this is where some foresight is encouraged, and it's going to pay off for you. What's cosine times cosine? Cosine squared. Well, that's good. If we get a squared, we can sometimes substitute stuff in. We got cosine squared over here. All right? Now, the denominator is sine. If you multiply top and bottom here by sine, what will you get in the numerator? And what's sine squared plus cosine squared? 1. So you can see that there's rhyme or reason. There's a path that's going to work out for us. So I'll write it out. We have sine of theta over 1 plus cosine squared of theta over sine of theta. Multiply top and bottom by sine. And again, when I do this, I kind of think about it ahead of time. What's going to come of this? Well, I get a sine squared plus cosine squared. That's pretty good. So who cares about the denominator? We'll figure that out later. Sine squared of theta plus cosine squared theta over sine of theta. What's sine squared plus cosine squared again? What's 1 over sine? Cosecant of theta. Why don't you try I on your own? See if you can get that to work out. I is very similar to H. Okay, give it a try. Okay, let's quiet down for the benefit of everybody. Oh, so you changed cosine to 1 over secant? I don't know if I ever change cosine to 1 over secant. And I don't know if I ever change tangent to 1 over cotangent. And I don't know if I ever change sine to 1 over cosecant. But I will change cosecant to 1 over sine. Okay, so the goal is to rewrite in terms of sine and cosine. Since cosine is already written as cosine, I'll leave it be. Okay, so I get sine squared theta over cosine plus cosine theta over 1. Hey, I've got a sine squared. I'll see if I can get a cosine squared. Multiply top and bottom by cosine. So you can see you get sine squared plus cosine squared. Raquel. Over cosine. What's that? It's a joke. It's Rachel Wallen. Yeah. I call her Raquel every time. What do you want? She doesn't deserve it. Okay. I will. Sine squared plus cosine squared is 1 over cosine is secant. All right, next problem. Again, I don't see any substitution right away. I'm going to rewrite. What happens? Very good. You get 1 minus sine squared, and as Will said, 1 minus sine squared is cosine squared of theta. Any questions there? Okay, so if I'm not helping you out at all, and you were doing this problem on your own, how would you start letter K? What would you do? Okay. Very good. Shave says to take out a cosine squared. That's the right step here. Take out a cosine squared. What are you left with? I have a formula for 1 plus cotangent squared. I'm sorry, I have an identity. What is it equal to? Cosine squared times cosecant squared. What's cosine squared over sine squared? Colton just said something important. He said, I like this stuff. Some of you guys are recognize that you actually do kind of like this, even though you don't see a natural purpose for it. So that's good. Let your math nerdiness come out. Embrace it. Maddie? Good. Last one. I'm going to distribute. What's the relationship between cosecant and sine? They're reciprocal, so when I multiply them, I get 1 minus 1 minus cosine squared. Sine squared. Okay, I went through that pretty quickly. I'd like to do one more problem that I left out in the notes that from now on I'm going to put back in. So. Okay, so we're gonna do an extra problem. We're gonna do tangent of x divided by tangent of x plus cotangent of x. You put it wherever you want. Yep. There's gonna be a lot of space taken up there. Okay, so this is a no. He's referring to the problem. Okay, I don't think this is gonna take a lot of space. Just write small. Just put it right up to the right-hand side of the last problem. Okay. All right. So sometimes what we need to do is, as we change from sine to cosine and whatnot, we have to trust that as it's written as a fraction, that things will reduce. For example, sine divided by cosine is tangent. A lot of times when you have fractions in trigonometry, if we could just divide them or kind of work out the complex fraction, we'll arrive at a solution. So what I'm going to do here is I'm going to try to combine these a little bit. I'm going to write this as sine of x over cosine of x divided by sine of x over cosine of x plus cosine of x over sine of x. Can you see that that is a complex fraction? So sometimes it's advantageous for us to create the complex fraction to see what will simplify. In order to simplify a complex fraction, I should have one fraction in the numerator and one fraction in the denominator. I currently have two fractions in the denominator, so I need to find common denominators. Top and bottom by cosine. Top and bottom by sine on this side, cosine on that side. That way, what's in my denominator? What's my new denominator? Sine of x times cosine of x is in my denominator. So what I have here is sine of x over cosine of x divided by my numerator, or the denominator, will be sine squared plus, is that good? Yeah, what is sine squared plus cosine squared? It's just 1. So you get sine squared plus cosine squared over what? Sine of x cosine of x. Now, you all just told me that's going to be 1, right? So now I can multiply by the reciprocal. If I multiply by the reciprocal, I multiply by sine of x times cosine of x over 1. What happens? Cosines cancel. You get sine squared of x. So it may not be obvious to us right away that tangent of x over tangent plus cotangent gives me sine squared, but it does. And by working through that kind of complex fraction, we can see the solutions. Okay, so for this section, okay, I want you to be able to do problems 1 through 22 all. Now, yesterday you already did some of those. The ones you haven't done yet are 7, 11, and 14 through 22. So you can think of the assignment two ways. If you didn't do any work yesterday, your assignment is 1 through 22 all. If you did the assignment yesterday, then add 7, 11, 14 through 22 to your assignment. You just add it on the end. But I'll say it one last, no, I'm going to say it again and again and again. This fourth quarter that we're going to be coming upon not too long, trigonometry, has brought upon many D's and F's. Many, many, many. Okay. How about this? If I think that my lowest number of D's and F's in a second semester trigonometry over the past few years, and that means D or F does not get college credit. The lowest number of D's and F's that I've had, I think, is probably 4. So, so please stay on top of your work. This is tough stuff. Go.